with frequency tables, and levels of measurement. So congrats to you for having made it this far. Keep it up. Keep up with your schoolwork. Keep up with Newton. And please know that any questions at all, like it's not too small. No question is too small or too large. Please feel free to email me or tune into my Zoom meetings, okay? Where I answer questions from the homework. Alrighty, so 1.3. Let's talk about answers and rounding off. A lot of times we have that question like, oh, when do we round? When do we round? When do we round? So general rule of thumb is we usually round at the end, and we try not to round in the middle of our calculations because sometimes that will lead to mistakes. So we don't need to. We need to try to at least do twice as many. If we do have to round off, like in the intermediate, try to do at least twice as many decimal places as the final answer. In Newton, it usually will tell you round to 2 decimal places or 1. Personally, for me, it's 2 is good, 3 is good, 4 is great. It's all the same. So as long as you're rounding correctly. To me, it's more important that you round correctly and that you know the rules for rounding. Okay, so like for example, if I wanted to round off 6.3 to the nearest whole number, it would be 6 because the 3 is less than 5, and so we keep the number. Okay. All right. Fractions we usually keep as is, and we don't reduce, simply because, which is kind of hard for me my background is in theoretical math, pure math. So it's kind of hard for me to say that, but it is in statistics. It's helpful because you can see what fraction of that. You'll see what I mean as we start doing problems. But yeah, so you don't really need to reduce fractions in this course. Okay, it's actually more helpful to leave it not reduced. Okay, all right. So levels of measurement. Okay, so we've talked about data. We've talked about types of data. Now we're going to continue with talking about levels of measurement. So in order to familiarize ourselves with the different levels, okay, we need to understand that there are different types of levels, and we can classify data in this way. Okay, so from their lowest level, and then they become increasingly more with more conditions. So you have nominal scale level, ordinal scale level, interval scale level, and ratio scale level. So I'm just going to go ahead and talk about each one. Okay, so nominal, I'm going to begin with nominal. Data that's measured using a nominal scale is qualitative. So that is categorical. So like, for example, categories, colors, names, labels, and favorite foods, and yes or no responses are examples of nominal data. Okay, so it's not ordered. There is no ordering. You can't say, I guess like alphabetical ordering, but really not. It's not like this is greater than that. This has more weight. That's a number thing. So we can't order people according to their favorite food, right? We can't put veggie pizza first. Oh, that's misspelled, sorry. And then vegan sushi second. It's not meaningful. So here's a helpful table, and it's going to follow us, and it talks about the different levels of measurement and what they do. Okay, so do they put data in categories? Do they arrange data in order? And as you can see, nominal is basically just categorical. It does not subtract, and you can't subtract, and you can't determine if one is a multiple of the other. Now, ordinal scale is data that is measured similar to nominal, but the difference is that ordinal scale data can be ordered. Again, so nominal, name, ordinal, order. You see, we're not very creative. The name is the definitions in the name as well. So example of ordinal scale data would be a list of the top 5 national parks in the United States. So we can rank them from 1 to 5, but we can't measure differences like how much more 1 is it, you can't really do that. So that's just the rankings. Okay, so that's ordinal. Now interval data using the interval scale is similar to ordinal because it has an ordering. But there is a difference between the data. So let's say, for example, temperature scales. Okay, so you can subtract the data values from each other, and it makes sense. Okay, so when you have in the land of temperatures, let's say 40 degrees is the same as 100 minus 60. So you could use intervals to describe this data. Like let's say and we see it all the time in the weather. Oh yeah, Monday is going to be in the 80s and whatever. They're just, we see this. Okay, so the other thing about interval is that it doesn't have an absolute zero. So there's no bottom. So like temperature, there is a 0 degree, but that's not the coldest, right? Negative degree temperatures exist, okay, and they're colder than 0 degrees. So in a sense, it doesn't have like a floor. Theoretically, you could keep going more and more cold. I mean, yeah. So it's that's a little different. And in your guided notes, you have this to fill out. So if you need to pause me, go ahead. Feel free anytime. Pause the video and handle your thing. So next is ratio scale. Okay, so data that is measured using the ratio scale takes care of that problem and gives you the most information. So ratio scale data is like interval scale, but it does have a 0 point, and ratios can be calculated. So for example, for multiple choice statistics, final exam scores are 80, 68, 20, and 92 out of 100. The exams are machine graded. The data can be put in order from lowest to highest. And the differences have meaning. So like 92 is more than 68 by 24 points. You can calculate ratios. So the smallest score is 0, okay? You can't get a negative on an exam. You just get 0 points. And so also consider that like in a test, 80 is 4 times 20, so you would say, okay, my score of 80 is 4 times better than this unfortunate person who scored 20 on their exam. Okay, all right, so that's it for scales. There it is. So 7 occurs once, right, in the data. So there you go. And then 6 occurs twice, and then 5 occurs 6 times. So the total number, if I was to add all these frequencies up, I should get the total sample size, right? How many students were interviewed? 20. So if I add all these up, go ahead, do it if you don't believe me, and you'll see that you get 20. Okay, so very cool. All right, so what's a relative frequency? So that's also interesting. So relative frequency, so this is something you need to know too. It's a ratio, which is also you consider a fraction, or it can be expressed as a proportion of the number of times a value of data occurs in the set of all outcomes to the total number of outcomes, okay? So in this example, so how do you find the relative frequency? You divide every single frequency by total number of in the sample, okay? So in this specific case, the total was 20, right? So if I had here the data values, here's how many times each data value occurred, the frequency, we just defined that. Then the relative frequency would be like, okay, well, data value 2 occurs 3 out of 20 times, so it's 15% of the time. 15% of the data is 2, okay? And then you could say, okay, well, data value 3, the number 3 occurs 5 times out of 20, so 5 out of 20, 1/4 of the entire data is 3, I'm sorry. So since 3 occurs 5 times, it occurs the relative frequency is 5 out of 20, okay? And so on. So you can express it as a decimal or as a fraction. The interesting thing to note is that when you add all of these up, you should get a total of 1.00. Sorry, that's really terrible, but that's 1. So 100% or 1 point, this is a decimal. Sorry, it's a very poor decimal. 00. or you would get 20 out of 20. So it would be, if I was to add all those fractions up, I would get 20 out of 20. Oh man, this is great. Okay, yeah, so 20 out of 20. Okay, finally, let me introduce a CRF. So the word cumulative, what does that mean? The word cumulative in this case, and also other cases, is everything that has happened before up to this point. So cumulative. So when they say the final exam is cumulative, you know that it's going to talk about everything before. And that's kind of like the exam that we're like, uh-oh, but it's fine. It's not scary. So cumulative is the frequency, it's accumulation of the previous relative frequencies. So what we do here is we take the relative frequency and we add the ones before it, and that's our cumulative relative frequency, okay? So let's go ahead and think about that. So the first data value is 2. It occurs 3 times in our data set. The relative frequency is 3 out of 20, which is 15%. There's nothing before it, so cumulative relative frequency will just be 15%. Okay, so now data value 3, it occurs 5 times. The relative frequency is 5 out of 20, or 0.25. The cumulative relative frequency would be the one before it plus the 0.25, so the CRF is actually 0.4. Okay, so then 4, 3 out of 20, 0.15. So you take the one before it, add to it 0.15, and that's equal to 0.55. Okay, so basically just keeps adding on top of each other. You can also do this with fractions. So this would be 3 out of 20. This would be 8 out of 20. This would be 11 out of 20. So you see what I'm saying? So it would just keep accumulating. And eventually, since you're adding all the ones before it, and the last value should be 1, which we just said the sum of all the relative frequencies is 1. So the very last point, or the last entry for the value of its cumulative relative frequency should be 1, because you're adding all the cumulative relative frequencies, the relative frequencies before this data set. So that's what that means. So cool. So like if I add all this together, that's 1. If I add all these together, that's 0.95. If I add all these together, that's 0.85. If I add all these together, that's 0.55. If I add all these two together, that's 0.4. And if I add this to nothing, it's 0.15. Okay, so so here's a table, and we're looking at the heights of soccer players. So this is just like one way they could have organized their data. They gave us a table where, their heights in inches are from this feet. There's 5 of them. Inches. There's 5 soccer players that are between 59.95 inches and 61.95. Okay, so that occurs 5 out of 100. 3 of them are a little taller, between 61.95 and 63.95. Here's 15, and then 40, 17, 12, 7, and 1. And so the total number is 100. The relative frequency is frequency over 100. So each one of these numbers over 100, you see that right here. Okay, and that adds up to 100 over 100, which is 1. Okay, so here it is expressed as decimals. And then the cumulative relative frequency, you take that 1, okay, fine. You take this one, add the one before it, okay, fine, that's 0.8. You take this one and you add everything before it, that's going to be 0.23. You see what I'm saying? You can take, and then you can just kind of shortcut. You can say, well, since this is the sum of these 3, the next one will just be this plus 0.4, so that's 0.63. And the next one will just be 0.17 plus the sum of the 4 before it, which is 0.8. So instead of just going up the list a bunch of times, you can start using it to continue. Okay, so that is it for 1.3 actually, and your super fun homework consists of 1 problem. But don't be fooled, this problem has I think it's like A through F, but it's still not a lot. So cool. All right, so I will see you guys on the next video, and good luck. Happy studying.